So I want you to follow along with this video. In this video, I'm going to graph the example data that you have in your lab handout. And this is data provided by Dr. Gifford on the incubation time of prairie lizard eggs from Arkansas and Missouri. Okay, so they were collected in the wild and then they were all brought back to a lab and then incubated at the same temperature. And we're going to see which ones hatch faster. Okay, now the first thing we should do, I'm going to go to a Word document here, is write our hypothesis, our biological research hypothesis. And these are written if, and then. Okay, if and then. After the word if, you put your hypothesis. And a hypothesis is, by definition, an explanation. So if climates are different in Arkansas and Missouri, comma, causing lizards, I should put the species name here, but prairie lizards, causing lizards to be adapted to those climates. And after the word and, we put what we're going to do. And prairie lizard, I always misspell prairie. And another thing you could do here is put the actual scientific name, which I have not typed out here. That's another thing that you could put in your hypothesis. And prairie lizard eggs are from Arkansas and Missouri, are collected and incubated at the same temperature, comma, let me fix Arkansas there. Okay, then now we have to make a prediction. In this case, I'm going to make a very vague prediction. Then the incubation times between the two populations will be different. All right. Now let's just look at what I've done here. I have if, let me color code this. Let me make this red. If climates are different in Arkansas and Missouri, causing lizards to be adapted to those climates. All right. What I'm saying there is maybe it's a little bit cooler in Missouri than Arkansas. Maybe the weather's a little different. So the prairie lizards here are going to have slightly different incubation times than in Missouri is my idea. So they're adapted to different climates. Okay. So that's my hypothesis. That's my explanation as to why there might be a difference in incubation times. And after the word and, I have my procedure. And prairie lizard eggs from Arkansas and Missouri are collected and incubated at the same temperature, comma. Then I put my prediction, what will happen if my hypothesis is supported. Then I'll color code this one blue. Then the incubation times between the two populations will be different. So I'm not going to predict which one will be faster or slower in this example. I'm just going to predict that they are different. So then I can write my statistical hypothesis. This is what you actually test when you run a t-test. So H0 stands for null hypothesis, which is that there might not be any difference between the two. So there is no significant difference in incubation times between the two populations. And H1 is there is a significant difference in incubation times between the two populations. Now, if I had made a prediction that Missouri will hatch faster, let's say, I would have to run a one-tailed t-test. But I'm predicting difference, not direction. So since I didn't predict a direction, we're going to run a two-tailed t-test when we run that test here in just a little bit. Okay. So here's the data, and we need to first calculate the mean. Then we need to calculate standard deviation, and then we're going to make calculate standard error. So to calculate the mean for the Arkansas lizards, you simply click in this cell. You put an equal sign, that's how you start a formula, and you type the word average, and you open a parenthesis, and you highlight this data. Now remember to write down these instructions so you don't forget, okay? And you close the parenthesis, and you hit enter. There's the average. or mean for the Arkansas population. Do the same thing for Missouri. Equals average, open a parenthesis, highlight the data, close that parenthesis. Oops, I did something wrong. Equals average. Okay, there we go. So we can see that the averages are a little bit different, but you can't say they're significantly different until you do more testing, okay? Now, standard deviation, the way you calculate that, this is a measure of how varied the data was around the average. You put an equal sign, and you type in equals, STDEVA is the abbreviation. You open a parenthesis, and you highlight Arkansas incubation times, and you hit enter. Now, I'm going to give you a little secret. If there's the same number of samples in each population, you can just copy and paste this value over here, and it pastes the formula and not the actual the number. But just to remind you what the formula is one more time, it's equals STDEVA, open a parenthesis, then highlight all the numbers for Missouri, not the average, but the raw numbers for Missouri, and close the parenthesis and hit enter. So there's the standard deviation. And the last thing we want to do is calculate standard error. So this equals this equals we put an equal sign, then we click on the standard deviation for Arkansas, and then we put a divided by sign, so a slash, and we're going to divide by the square root of the number of samples. And to do that, square root is SQRT. And we open a parenthesis, and there are 10 samples here, so we put that in parentheses. So what we have here is the standard deviation divided by the square root of the number of samples, and we hit enter. Okay, so that's our standard error of the mean. Over here we do the same thing, equals STDEVA. I'm sorry, I shouldn't have done that. Equals, we click the standard deviation, sorry, divided by the square root of the number of samples. So once again, it's the standard deviation, in this case, which is 0.966, divided by the square root of 10. And there's the standard error for that population. Now, what I do is I'm going to go ahead and copy the titles of these two columns right there. And I'm going to highlight the averages and the column titles. And I'm going to go to Insert up here. And I'm going to insert a column graph. Okay, the reason I highlighted these titles is so it put it right there, right under the columns. First thing I'm going to do is delete this thing that says chart title, and I'm going to delete these lines that don't really serve any purpose. Okay. Now, in order to insert our error bars onto this graph, I click this little plus symbol. And I'm going to go to error bars. And now it puts error bars on there right away, but they're not correct. Okay, so what you have to do is you have to click this little arrow next to error bars. And remember, if you have a Mac, this will be a little different, but it's pretty similar. Go down to more options. And if you do have a Mac, Google error bars and things like that on, well, look it up on YouTube and you'll find some ways to do that. Custom error bars is what we want to do. And we click on specify value. And then it has this option, positive error value and negative error value. If you click this little arrow next to positive error value and you highlight both of the standard errors that you've calculated, okay, click the little arrow again. Then for negative error value, highlight the exact same two numbers again, and then click OK. And now we have our error bars. One way that you can tell if your error bars are likely correct is if the error bars are different lengths. That's usually a good sign. If they look exactly the same, that's often a problem. In this case, they look about the same, but it's not a problem because notice the standard error here is 0.32, and for this one it's 0.31 essentially. They're almost the same calculations. But if this was like 0.5 and this was 0.2, but the error bars look the same on the graph, that would be a problem. One should be longer than the other. Okay, the other thing we want to do here is we want to insert axis titles. So we click the little plus symbol next to the graph, and we go to axis titles. And then down here, I'm going to just put location. And then for the y-axis, we're going to put incubation time, and then days is the unit. And then what I need to do is I need to drag this a bit, make it a little easier to manipulate. I need to move this or change the font size, because right now it overlaps with the words a little bit and kind of looks like crap, and we don't want our graph to look like crap. So I'm going to shrink the text slightly and get that out of the way slightly. It's kind of hard to get it to go where you want. All right, I'm going to leave it like that for now. Okay, if I had time, I'd fiddle with this more and get it so it doesn't overlap the numbers, but I don't want this video to go for 4 days. Okay, so then what we do, let's say we go to a Word file. Here's where we have our hypothesis. Let's say we're going to go in here and we paste our graph in here. Then what we have to do is write a caption. Okay, you type underneath the graph and then you would write the figure caption. I'll do another video on that in just a bit.